All right, this is our solutions video for quiz 7.4 to 7.6. The gravitational force between two masses, M1 and M2, is proportional to the product of the two masses and inversely proportional to the square of the distance, d, between the two masses. Write a model that represents the relationship between the force, the two masses, and the distance, d. So let's read it again. The force, F, the gravitational force, which they have defined as capital F, between two masses, M1 and M2, is proportional. That phrase is proportional is the same as varies directly to the product of the two masses. Okay, so I have F is proportional or varies directly to the, so I've got some K constant to the product of two masses, product of the two masses, product, that's multiplication. And inversely proportional, that is the same as varies inversely, okay? And that will be over the square of the distance d, d squared. So there's your answer. Okay. Next, identify if the relationship is direct variation, inverse variation, or neither, and if the relationship is direct variation, inverse variation, make sure you write the equation, including the K constant. Well, let's refresh our memory. Direct means that y is equal to some K constant times x, which means I will have a constant value if I divide y by x. Inverse means I will have y equal to some constant divided by x, hence the word inverse. That means K will be constant if you multiply y times x, okay? Now let's look at the two. Let's look at the products between x times y. 2 times 100 is 200. 5 times 40, 200. 20 times 10, 200. 8 times 25, 200. It would appear that when I multiply the two numbers together, I get a constant value. This data set has an inverse variation. The K constant is 200, and write an equation. Y equals 200, that's my K constant, over x. Okay. The length S that a spring will stretch varies directly with the weight F that is attached to the spring. So we have the length S, so we have S varies directly, that's like saying equals to, and directly, so I now have a constant times my F. There's my direct variation. Okay, and then they give me some information. They tell me that it stretches 20 inches when 25 pounds is attached. How far will it stretch when it's 15? Well, I've got to find K first. K is equal to 20 over 25. Divide 5. I'll divide each one by 5, and I get 4 over 5. And so I know that I have an equation. S is equal to 4/5 times whatever the weight is in pounds. And then they ask, how far will it stretch, which is S, if I have 15 pounds. So S is equal to 4/5 times 15. I can divide out 5. So 4 times 3 is equal to 12. And that is in units of inches. Left on together, the hot and cold water faucets of a certain bathtub take 10 minutes to fill the tub. I have a combined rate of 1 tub per 10 minutes. If it takes a cold water faucet 14 minutes to fill the tub by itself, how long will it take the hot water faucet to fill the tub on its own? Well, let's refresh our memory. So if I refresh my memory, I have a rate of my cold plus my rate of my hot is going to equal my rate of my combined. Okay. So rate of my, let's see what they gave us. The first one is left on together. So here's my combined. I get 1 tub in 10 minutes. So I have 1 tub in 10 minutes. What do we have next? It takes the cold water. So now I know the cold. I have 1 tub in 14 minutes. How long will it take the hot water faucet to fill? Okay, how long will it take it to fill 1 tub? How many minutes? We don't know. We got to multiply times X, or call the minutes X. Okay, I have 3 fractions. This is a rational equation. So I'm going to multiply everything by my common denominator, which is a 10 times 14 times X. I'm going to multiply the, don't forget my equal sign here. I'm going to multiply the entire right by that common denominator and my entire left by that common denominator. And when I do that, I get 10x plus 140 equals, and then my 10 cancels and I get 14x, and then I'll combine my x's and divide, and I will find x to be 35 minutes. And that was the time that the hot water took. I have a passenger train that traveled. So I have my passenger. The distance was 100 miles in the same amount of time. So I've got this T equals T. That it took the freight train some distance of 60 miles. Time is equal to time. The freight train has a rate of 30 miles an hour slower of the passenger train. So I'm going to call this rate for the passenger train X, and I'm going to call this rate for the freight train X minus 30, since it was 30 miles slower. Don't forget that the distance is equal to some rate times time. So the times are the same. So distance over rate is constant in this situation. So for the passengers, I have 100 miles over its rate, which we defined as X. And the freight went 60 miles over its rate, which was X minus 30. And now we need to find X. Now you can cross multiply, which is what most students would probably do, or you can think of it as multiplying everything by the common denominator, which is X times X minus 30. And what you do on one side, you got to do on the other, X times X minus 30. Same thing as cross multiplying, if you notice. Oops, I left my little 30 there. And what do you get when you do that? On the left, my X's cancel. I get 100X minus 30 times 100, 3,000 is equal to my X minus 30 cancel, and I get 60X. And yes, so I subtract 60, I get 40X equals positive 3,000. X is equal to 3,000 divided by 40 is 75. What is the value of X? It is a rate in miles per hour. There it is, miles per hour. All right, solve this equation. We're going to need a whole bunch of room here, unfortunately. Okay, here we go. We got to first get rid of all my fractions. What's my common denominator? I'm going to multiply both sides by my common denominator, which is y plus 3 times y minus 3. And what I do to one side, I must do to the other. And my common denominator is y minus 3, y plus 3. Now, we're going to take this whole thing and multiply it times the first term. When I do that, my y minus 3 cancels, and I get y plus 3 times y. Come on. Y minus 5. Okay, equals. Now I'm going to distribute this into this term, and then I'm going to multiply it into that term. When I multiply it to the first term, which is y minus 3, my y plus 3's cancel, and I get y minus 3 times y minus 3. And then I'm going to add it to my next one, and my y minus 3 cancels, and I'm left with y plus 3. Now I got to do some simplifying. So on the left, that will simplify into y squared, and then I have a negative 5 and a positive 3 that gives me negative 2y, and then a negative 15. And that will equal, and then I have to multiply that out. That'll give me y squared. And then I will have a negative 6y plus 9. And then I still have a plus y plus 3. Might think it's quadratic, but it's not. My y squares are on both sides. I can subtract those out. Now let's focus on my y's. Okay, on the right-hand side, I have negative 6 and a positive that gives me a negative 5. I'm going to add 5 to both sides. I'm going to add 5 over here. 5 plus 2, negative 2 is a 3y. I'm going to move all my constants over to the other side. So I have on the right-hand side a positive 12 that I'm going to add 15 to. That'll give me a positive 27. And I'll divide by 3. Y is equal to 9. Now let's double check. Does 9 give me any problems? It does not. It is not an extraneous solution. My answer is y minus 9, or y equals 9. Solve the inequality. First thing we need to do is get everything over to one side of the equation. 16 x plus 3 minus 2 less than or equal to 0. I need to get everything, I need to get a common denominator under that 2 so I can combine those two terms. What's my so what is it missing? It's missing my x plus 3. So I'm going to multiply x plus 3 over x plus 3 times that negative 2. When I do that, my denominators will be the same. So I will have a common denominator of x plus 3. My first term, I still have 16. My second term, don't forget, I have to take that negative 2 and multiply it through both of those terms. And I will have minus 2x minus 6 is less than or equal to 0. Now let's rearrange this equation, and combined, I get negative 2x on top. 16 minus 6 is a positive 10. Yep. And then on the bottom, I have x plus 3. All of this is less than or equal to 0. Now I've got to decide, where is my function undefined? It is undefined if x is equal to negative 3. Where do I have zeros or intercepts? Well, that's when the numerator is equal to 0. Where is the numerator equal to 0? Negative 2x plus 10 is equal to 0 when x is equal to a positive 5. So you would subtract 10 from both sides, divide by negative 2. So that happens when x is equal to positive 5. Now you're going to go to your number line. You have negative 3. You have a positive 5. And you're going to be super careful because we have undefined at 3. And at 5, I have a 0. And we're going to pay attention to the fact that it's less than or equal to 0. So this is true. And this is false. Why is that false? Because it's undefined, so it cannot be part of the solution. Then I'm going to look at numbers that are to the left of negative 3. I don't know, pick negative 10. Plug in negative 10 for x. Negative 10 times a negative 2 is a positive 20 plus 10. That's a positive on the top. Negative 10 plus 3, it's a negative on the bottom. That means I have a negative. Is that less than or equal to 0? Yes, that is less than or equal to 0. If I have a number between negative 3 and 5, let's pick 0. I get 0 plus 10, I got a positive on top, 0 plus 3, I have a positive on bottom. My value is a positive. This is false because a positive number is not less than or equal to 0. To the right of 5, let's pick 10. 10 times -2, -20. -20 plus 10 is a negative number. 10 plus 3 is a positive. That becomes a negative. This is true because I have a negative number, and a negative number is less than or equal to 0. Now let's look at what's true. Well, all of my values from negative infinity, not -3, doesn't include it because it was undefined there. How about on this side? Oh, 5 is included because that was a 0 and all the way to infinity. So now let's write this in set notation. I'm going to start with negative infinity. I'm going to go all the way up to -3. Negative infinity is never bracketed. 3 is not bracketed because of the fact that it is undefined. So they're parentheses. Then it's going to union with 5 all the way up to positive infinity. 5 is bracketed. Infinity is never bracketed. And here is my answer set. Okay, let me leave that there for a sec. Okay, now let's look at graphing. We have 4 graphs. Let's refresh our memory on all our steps. Okay, first thing we're going to do is going to factor. And this will factor into x minus 3, x plus 2. Two numbers multiplied by -6, add to -1. We are going to find our domains. All reals except for values that make the denominator 0, which is +3 and -2. Now we got to ask ourselves at those locations, do I have a vertical asymptote or something else? If I have a number in the numerator when I approach 3 or -2, then I have an asymptote. And that's the case because for either one of those, 3 or -2, my numerator is going to stay 12. So I have a vertical asymptote, which I'll give abbreviation as VA at x equals 3 and x equals -2. What's the next step? Well, we look at our horizontal asymptote. How do I do that? I look at in behavior. I look at dominant terms. What happens as x approaches infinity or negative infinity? Well, in this case, my denominator gets huge and my numerator stays the same. So I have a horizontal asymptote at y equals 0. If I have a horizontal asymptote, I cannot have an oblique asymptote, so I'm good. Zeros or intercepts. So where is my output 0? That means where's my numerator 0? There is no value that makes my numerator 0 because my numerator is always 12. So there's nothing that will make my y output 0. Now let's graph. Let's see if we can do that a little better. Okay, I got 2 vertical asymptotes. X equals 3. X equals -2. No intercepts, horizontal asymptote at y equals 0. All right, I have how many regions? We got 1, 2, 3. Those are the only regions where I can switch signs because I don't have any intercepts. I got to look at to the left of -2. Plug in some value bigger than negative, or to the left of -2. Let's pick -10, 12, which is positive. -10 minus 3, that's negative. -10 plus 2 is negative. Negative times a negative, so I'm going to be positive. So I got to be up here. And in the region between -2 and 3, let's pick 0. So if x is 0, up top is positive. On the bottom, I've got -3 times 2. And in fact, that'll be -6. That'll actually be a -2. So when x is -2, y is -2. And so didn't have to label that. It said only asymptotes zeros. That's considered x-intercepts and holes. I'll have to ask about that one. Anyway, there's your y-intercept of -2. Okay. Let's continue on. Oh, nope. Got to do one to the right of x equals 3. When x is, I don't know, 10, I get 10 minus 3, that's positive. 10 plus 2, that's positive. I got a positive over positive, and there's your answer. No point defined is necessary. Okay, I'm kind of getting big here. Okay, here we go. What do we have to do here? Well, what's my domain? Domain is all x's except for 2. Do I have a horizontal asymptote at x is equal to? Well, when x is approaching 2, what's happening to my output? Well, y is approaching 4, so sure enough, not a horizontal, I'm so sorry, vertical asymptote I do at x equals 2, right? Okay, what about a horizontal asymptote? What happens as x approaches infinity? Horizontal asymptote, I do not have that, none. Why is that? It will simplify into x squared over x equals x. That's infinity. It becomes unbounded. So we are going to have to probably assume there's a oblique asymptote. How do I find my oblique? Well, I've got to divide out the numerator. How do I do that? We're going to use synthetic division. So we're going to switch the signs. 1 is the coefficient in front of x squared. 0 is the coefficient in front of x. 0 is the coefficient in front of x to the 0. So let's do our synthetic division. We pull down the 1, we multiply by 2. 2 plus 0 is 2. 2 times 2 is 4. 0 plus 4 is 4. This equation is the same as x plus 2 plus that remainder, which is 4 over x minus 2. I'm going to rewrite that over here. So that is the same, y equals, or how about we say it this way, f of x is equal to x plus 2 over that remainder, 4 over x minus 2. Okay, so once again, we're trying to determine our oblique asymptote. As x heads to plus or minus infinity, what's happening to this remainder? It's getting smaller and smaller and smaller, and I'm getting closer and closer and closer to that equation for a line. So I have an oblique at y equals x plus 2. Okay, do I have any zeros? Yes, I have a 0 at x equals 0. My numerator will be 0 at x equals 0. Now I have all the pieces. Let's see what it looks like. I'm going to have a vertical asymptote at x equals 2. I have no horizontal asymptote. I have a 0 at x equals 0. I have an oblique asymptote at the equation of y equals x plus 2. Well, when x is 0 on that line, y will be equal to 2. So we'll put that there. We'll call that 0, 2. And when y is 0, x is negative 2, because it's going to have a slope of negative 1. Not that you have to put that there, I'm just showing you. Okay. All right. So we have something that looks like that. And I have a region to the left of that. I have a region between that 0 and the vertical, and I have a region to the right. Where it crosses the x-axis on the horizontal or the oblique asymptote does not define a region, by the way. We only have changes in regions at zeros, x-axis, okay, where it intercepts the x-axis, and the vertical asymptote. So I have 3. So I have to go through this intercept, which means there's no option other than that. Now we have to pick a number to the right of 0. If we pick, for example, I don't know, 1 squared is 1 over 1, we're negative. So now I know I look like that. And then I got to pick a number to the right of x equals 2. You'll find it to be positive, and it can only be above because I don't have any x-axis intercepts because I would have had another 0. And so this is the graph. Okay. And so all you have to label is my zeros. You have to label the obliques. So we probably should have wrote y equals x plus 2. And I've labeled my vertical asymptote x equals 2. That's all you have to label. All right, let's see if we can keep it in the box here. Next. All right, domain. Well, when does x squared plus 25 equal to 0? none. You can solve for it. It's undefined, all reals. There are no values. Okay, therefore, vertical asymptotes, none. No holes either. Okay, how about horizontal asymptotes? Got to look at M behavior. X squared cancels out with X squared. My horizontal asymptote happens when Y equals 10. So as X approaches infinity, my output approaches 10. So that means there's no obliques. Do I have any zeros? In other words, what values of X makes my value, my output 0? So look at the numerator. Sure enough, I have one at X equals 0. Okay. Because when X equals 0, X0 squared is 0, 10 times 0 is 0. So any number, or 0 divided by any number is equal to 0. All right, so what does this look like? We don't have any verticals, but we do have a horizontal at Y equals 10. We have a 0 at, so we cross the x-axis or touch the x-axis at 0, 0. And that's all we got. So to the left, I got two regions. I got one to the left, one to the right. Have to be headed towards that horizontal asymptote as X approaches negative infinity. Have to be headed towards that positive, that horizontal asymptote as X approaches positive infinity. There's your graph. Okay. Next, this is a good one. So let's simplify that. I'm going to factor out a 2. X minus 2 over the bottom becomes X minus 2, X minus 6. X minus 2 cancels. So G of X will simplify into 2 over X minus 6. All right, domain. You've got to ask that question before simplified. What values of X make that equation 0? That I cannot have 2 and I cannot have 6. Okay. Well, now I've got to ask what's happening to my numerator as my, or what's happening, do I have a hole or do I have a vertical asymptote when X approaches 2 or 6? So plug in 2. If you plug in 2 for X, and you can look at your simplified version, 2 over, well, 2 minus 6 is negative 4. So I actually have a value. So as X approaches 2, I'm approaching the value 2, comma, negative 1/2. So I have a hole at that location. When X approaches 6, the denominator becomes 0 and the numerator stays 2. So I have a vertical asymptote at X equals 6. Okay. Let's see. How about a horizontal asymptote? Do I have a horizontal asymptote? Well, let's look at our leading terms. So I get 2 over X because my X, one of my X's will cancel. And sure enough, I have a horizontal asymptote at Y equals 0, which means I have no oblique asymptote. What values of X will make my numerator 0? So let's go back to the original equation and you will find that I can have a 2, except that notice that 2 is not in the domain. And so none, we have no zeros. All right, we're ready to graph. How do we do that? First, we do our vertical asymptotes, which occurs at X equals 6. We are going to draw our horizontal asymptote at Y equals 0. I'm going to go and plug in my hole at 2 negative 1/2 and label it. And that's no zeros. I have 3 regions. I have a region to the left of the hole because I have to go through that hole or to that hole. I have a region to the right up to that vertical asymptote, and I have a region to the right of the vertical asymptote. So hopefully it makes sense that I got to come from that hole and approach my horizontal asymptote. Now I probably have to plug in a number to the right of 2 to see, do I stay positive or negative, which it'll end up staying negative, but let's plug in a number real quick. If we have a value of, I don't know, 3, 2 over 3 minus 6, that's negative, so we're headed this way. Now we've got to figure out, are we above or below the x-axis? And so let's pick something like 10. 2 over 10 minus 6, that's positive, so we're up in this region. And that's how you would graph it. Everything's labeled. Hope that makes sense. And with your studying and practice,